Part A, to determine the exact value of P. So P is this value here, which is the probability of selling a pie. So for a new customer that comes up to Nancy's counter, she is selling 6 different items here: cakes, muffins, pies, cookies, brownies, bread. Sounds like a very nice bake sale. I wouldn't mind going to that stand. It looks very good. The probability of selecting one of the items is shown here in this bottom row. The price of each item is shown in the top row, but for this question here, we are looking at the probability of selling an item. Now let's assume that each customer definitely does buy something, so there's no probability of, say, the customer saying, no, it's okay, thanks Nancy, I'm not going to buy anything. So if a customer has to buy something, they're going to buy one of these 6 items. So the probability needs to add up to 1. I have the other 5 probabilities, so I can therefore find P by adding these up and making that equal to 1 and then solving for P. So that is what I did here. So I said, let's add all the probabilities up. If the customer has to buy something, the probability is going to equal 1. On the left-hand side here, I now collect like terms. So I add the fractions together. All these fractions here are equal to 14 on 15. So I have P plus 14 on 15 is equal to 1. I now solve for P by subtracting 14 on 15 from both sides. So 1 subtract 14 on 15. And I get a probability of a customer buying a pie of 1 on 15. Part B asks you to find the expected cost of an item sold and to round your answer to the nearest cent. Okay, so in this question here, we have a probability distribution table that shows the 6 different items that Nancy is selling. We have the price of the item. So for example, a cake costs $7 and we have the probability of the next customer that comes up to the stand, the probability of that customer buying that particular item. So for example, a cake has a 1 on 15 probability that the customer will purchase it. Cookie, on the other hand, has a higher probability, 1 on 3, but the price is lower. And it's our task to find the expected cost of an item sold. Now, this is a pretty common type question when we have probability distribution tables. It'll either say sort of expected cost, but the phrase is the expected value. Now, the way that we find the expected value for a probability distribution is to find the sum, which is this symbol here, find the sum of the multiplication of the outcome, in this case here, the price, by the probability. So in this case here, if we look at this line, we're finding the sum, so we're adding all of these brackets together, of the cost of a cake multiplied by the probability of the customer selecting the cake. We then add that to the cost of a muffin multiplied by the probability of the customer selecting the muffin, and so on and so on. And if we enter this into our calculator, we get a value of 2.07. And what this number here represents, if you were to survey, say, the first 100 customers to this bake sale, they would have all different amounts of cost. So one may have bought a cake for $7, one might have bought 2 cookies for $2, one might have bought a brownie for $1. If we were to average the total cost of an item out of all of that, we would get a value of 2.07. It's not just simply the average of the price of the item. That would be a mistake that I often see students make. They just average the cost. But if we just average the cost, we're not actually taking into consideration the likelihood of a customer buying that item. So there's less likely for a customer to buy a cake than they are to, say, buy a cookie or buy a cookie. So that right there is the average cost of an item surveyed over a large number of items, and we call that the expected value. Part C, we are told that Nancy sells 2 items to a student, so 2 items out of these 6 here. So for example, the student could have bought 2 brownies or a cookie and a cake or a muffin and a pie, so 2. Find the probability that she earns $10 exactly from selling the 2 items. Okay, so to approach this question, I have drawn a sample space diagram that represents the total cost that this student pays for buying 2 items. So you can see here I have the items, the price of the items here, in ascending order. So for example, this first one here would be the cost of a cookie, and then a brownie, and then a muffin, and then a pie, and then bread, and then cake, and likewise for the second item. And in the sample space, I have shown the sum, which would be the total cost of buying the two items. So for example, let's just pick a number here. Let's look at this $6.50 here. That would be the cost of buying the $3.50 item, which is a loaf of bread, and then also a $3 item, which is a pie. So this sample space shows the sum of buying two items. Now we are interested in the combination of items that produce a total cost of $10. Now there's only two ways that could occur. They are highlighted here in red. So the two ways, and it's actually kind of the same way, but just in two different orders, would be buying a $7 item, which would be a cake, and then buying a $3 item, which would be a pie. The second way that it can occur is buying a $3 item, a pie, and then a $7 item, a cake. So basically, it's actually only one way. It's pie and cake, but it can occur in two different ways. It could be pie first or cake first. So looking at this line of working here, what this line here says is, actually, let's disregard the two for now. This is the probability of selecting a cake where the price is 7. So that probability is 1 on 15. If I read that off my probability distribution table, multiplied by the probability of selecting a pie, which is also 1 on 15. We're multiplying the probabilities together because this is a multi-stage event, and think about that in terms of a tree diagram. If I do one thing first and then a second thing, so multi-stages, to find the total probability, I multiply their two probabilities together. It's multi-stage, we multiply their probabilities. I multiplied that by 2 because there's two different ways that it could occur. It could be a cake first followed by a pie, but it could also be a pie first followed by a cake. I could have also written this as two different brackets. So the first one being cake multiplied by pie plus pie multiplied by cake. That would also be valid, but I've just written this in shorthand and said, well, there's two different ways that it could occur, so I'm just going to multiply it by 2. So that's 2 times the probability of selecting a cake multiplied by the probability of selecting a pie. Now, we found that back in part A to be 1 on 15. And if we enter that into our calculator, we get this decimal here. So 0.00889. So quite small.